Have you ever wondered why a can of soda doesn't explode under the pressure of its own carbonation? It's all because of a fascinating principle known as chemical equilibrium. Today, we explore this intriguing concept that is at the heart of many processes we see around us. When we think about chemical reactions, we often imagine them as a one-way street. Reactants transform into products, and that's the end of the story. However, the reality is a little more complex. Many chemical reactions are reversible, meaning they can go both ways. Reactants can form products, but products can also revert back into reactants. Imagine a crowded dance floor, where dancers keep switching partners. As long as the rate at which partners are being swapped remains constant, the dance floor maintains a certain balance. This is the basic idea behind chemical equilibrium. It is a state of balance, not because the reactions have stopped, but because they are happening at the same rate in both directions. In a chemical equilibrium, the concentrations of reactants and products do not change over time. This doesn't mean that they are equal to each other, just that they are unchanging. It's like a tug-of-war game where both teams are equally strong. The rope doesn't move, but that doesn't mean the teams aren't pulling. Now, it's crucial to understand that reaching equilibrium doesn't mean that the reaction has stopped. The forward and backward reactions are still happening, but at the same rate. So it's a dynamic process, not a static one. What factors influence this equilibrium, you might ask? Well, there's temperature, pressure, and concentration. The French chemist Le Chatelier proposed a principle in the late 19th century that provides a framework to predict how changes in these factors will affect the equilibrium. According to Le Chatelier's principle, if you disturb a system at equilibrium, it will shift to counteract the change. For instance, if you increase the temperature of a system, the equilibrium will shift to consume that heat. If you increase the pressure, it will shift to reduce the volume, and so on. This principle helps us understand and predict how chemical systems will react to changes in their environment. So, to summarize, chemical equilibrium is a state of balance in a reversible chemical reaction where the forward and backward reactions occur at the same rate. The concentrations of reactants and products remain constant, not because the reactions have stopped, but because they are balanced. Factors like temperature, pressure, and concentration can shift this equilibrium, and Le Chatelier's principle can help us predict these shifts. From soda cans to car engines, understanding chemical equilibrium gives us insights into the world around us. It's a reminder that balance is not just a state of stillness, but a dynamic process of constant adjustment and readjustment. And that's the beauty of chemistry. It helps us make sense of the complex dance of molecules that underpins our everyday lives.